So this is a very important long question. Electric field intensity due to a group of point charges. If in a system there are a number of charge particles are found, then what is the electric field intensity at a point due to other charges? What is the electric field intensity acting at a point due to other charges? We will calculate. So it is a three-dimensional system. O is the origin of the coordinate system. Here a number of charged particles q1, q2, q3 up to qi are present. We will calculate what is electric field intensity at point P. We will calculate electric field intensity at point P due to all other charges. So बर्तमान आम इलेक्ट्रिक ए पॉइंट रे अन्य सब पार्टिकल केते फील्ड पकोछ आम बाहर करबा मनर एडा होची q1 चार्ज पार्टिकल एडी अछि एडी q2 चार्ज पार्टिकल अछि एडी qi पार्टिकल अछि एडी qn पार्टिकल अछि q1 रो पोजीशन वेक्टर होची r1 सिन q2 रो पोजीशन वेक्टर होची r2 सिन या रो पोजीशन वेक्टर होची r qi रो पोजीशन वेक्टर होची ri ओके एंड nth पार्टिकल या रो पोजीशन वेक्टर होची rn so electric field intensity at point P due to charge q1 is e1. Since the electric field intensity at point P due to charge Q2 is E2, etc. So total electric field intensity at point P due to all other charges is E. हमें E value हमें calculate करवा. Since the Q1 to P रो दूरता होची R1P, since Q2 रो P रो दूरता होची R2P, and QI रो P होची RIP, since इटा होची RNP. आउ P रो position vector होची R, that means origin to से R दूरता रे अछि. Okay, so this is a very important question, very important from the exam point of view. We will calculate it. Consider a system of n point charges consider a system of n point charges q1 q2 up to qn having position vectors r1 r2 up to rn are located in air medium are located in air medium with respect to the origin O. With respect to the origin O, we have to calculate the net electric field intensity, the net electric field intensity at a point whose position vector is r. କ'ଣ କରିବା ପି ପଏଣ୍ଟରେ ନେଟ୍ ଇଲେକ୍ଟ୍ରିକ୍ ଫିଲ୍ଡ ଇଣ୍ଡେକ୍ସରେ ବାହାର କରିବା ଯାହାର କି ପୋଜିସନ୍ ଭେକ୍ଟର ହେଉଛି R. So, according to principle of superposition, the total electric field intensity at a point due to a group of point charges is equal to the vector sum of all the is equal to the vector sum of the electric fields produced by each charge individually. Produced by so according to the principle of superposition, total electric field intensity at a point due to all the charges is equal to the vector sum of the electric fields produced by each charges individually. That is E equal to E1 plus E2 plus E3 up to En. So this is the net electric field intensity at a point due to a group of point charges. This is your question. Where E is the net electric field intensity at P and E1, E2 up to En are the electric fields at point P. The electric fields at point P due to charges Q1, Q2, Q3 up to Qn respectively. So E which tomorrow net electric field intensity at point P, and E1, E2, E3 are the electric fields at point P due to charges Q1, Q2, Q3 etc. Q1 charge रा या पर जति फील्ड पकेबो सेटा होची E1, सिने Q2 चार्ज रा या पर जति फील्ड पकेबो सेटा होची E2 हला ए प्रकार में देख। Imagine that a very small test charge plus Q0 is placed at P then according to Coulomb's law, the force acting on Q0 due to charge Q1 So imagine a small positive test charge plus Q0 is just placed at point P, then force acting on Q0 due to Q1 ketabo F1 equal to 1 by 4 pi epsilon Q1 Q0 by distance ro square, distance mana R1 pi ro square. So this is equal to keta so 1 by 4 pi epsilon 0 Q1 Q0 by R1 pi ro square to R1 pi cap. Where R1 pi cap is a unit vector in the direction from Q1 to P and R1 P and is the distance between, and R1 P is the distance between Q1 to P, and R1 P is between Q1 and P. ହେଲା सो जदि Q1 दा Q1 उपरे एति फोर्स पकोची ताहाले इलेक्ट्रिक फील्ड केते पडियो व्हाट इज द इलेक्ट्रिक फील्ड इंटेंसिटी एट पॉइंट P ड्यू टू चार्ज Q1 hence hence electric field intensity at point P due to charge Q1 is given by E1 equal କେତେ ଆସିବ E1 equal ଆସିବ F1 by Q0 so ଏଟା କେତେ କରିବା ଆମେ F1 by Q0 ଯଦି କରିବା ଏଠି Q0 କଟିଯିବ ଆଉ ରହିବ କେତେ ଆମର this is equal to ଆସିବ equal to 1 by ଏଟା ଆସିଲା ତମର question number 3. So electric field intensity at point P due to charge Q1 is given by E1 equal to F1 by Q0 equal to केते हबो तमरो F1 by Q0 कर दियो Q0 कैंसिल हो जिवो और रहबो केते 1 by 4 pi epsilon 0 into Q1 by R1 per square into R1 p cap. Okay. Similarly, electric field intensity at point P due to charge Q2 is given by E2 equal to ଆସିବ ସେମିତି ଯଦି E1 equal ଆସିଲା 1 by 4 Q1 by R1 plus square into R1 p cap ସେମିତି E2 କେତେ ଆସିବ 1 by 4 pi epsilon 0 1 by 4 pi epsilon 0 to Q2 R2p cap ହେଲା E3 E4 ଆସିବ and so on ହେଲା so ବର୍ତ୍ତମାନ କେତେ ଆସିଲା so electric field intensity at point P due to charge Q1 is E1 since the electric field intensity at point P due to charge Q2 is E2 so net electric field intensity at point P due to all the charges केते आसीबो हमरो hence net electric field intensity at point P hence net electric field intensity at point P due to a system of n-point charges due to a system of n-point charges equal to this number equals la E1 plus E2 up to En. এটাকে আমি দেওয়া ইকুয়েশন 4, এটাও দেওয়া আমি ইকুয়েশন 5. So putting the values of E1, E2, E3 up to En, or E equal কত আসবে আমরা? E equal আসবে 1/4πε0 কমান বার করে দিও Q1 by R1 per square 1 pk plus Q2 by R2 per square R2 pk plus Qn by Rn per square into R np cap. Rnp cap. Or E equal to the 1/4πε0 into I equal to 1 to n Qi This is the expression for the electric field intensity due to a group of point charges. Or your unit vector equal to directional vector by magnitude vector, or E equal to E equal to 1/4πε0 sum over into Qi by Ri per square unit vector equal to directional vector by magnitude of vector. Or E equal to 1/4πε0 I equal to 1 to n into Qi by দেখতে পাবো লেখা তোমরা R square into R equal to R cube. So this will be the Qi by R IP rho whole cube to R IP. Number 7. So, and in terms of position vectors. Equation 7 can be written as so আমরা কেতে আসবে এটা আমি যদি এটা বুঝদি ट्रायंगल ओ এটা দেবা আমি এ বলি দেবা এটা আমি বি বলি দেবা ওকে এটা মনে আমি সি বলি দেবা এটা যদি আমি ডি বলি দেবা হ্যাঁ in triangle OAP kita masih bro OA plus AP equal to OP और OA equal कितना वो R1 plus AP equal कितने R1P equal to OP equal कितने R और R1P equal कितना आसबा हमरा R1P equal आसला R minus R1 हाँ सेंदे R2P equal कितना आसबो R2P equal कितने R minus R2 exactly हाँ RIP equal कितना आसबो exactly in the same way RIP equal कितना आसबो हमरो R minus RI बुझे सो आम के लिखा RIP को लिखा into QI by RIP को क्या था R minus RI whole cube into RIP को क्या पकेगा R minus RI That's number equation 8. So equation 8. So equation 8 is the required expression. Is the required expression for the electric field intensity or the electric field intensity due to a group of charges. So if in a system there are number of charge particles are found, then electric field intensity at point P due to a group of point charges equal to how much? This is equal to 1 by 4 pi epsilon 0 into Qi by R minus Ri the whole cube into R minus Ri. Equation 7, 8. Equation 8 and 7. Okay. Equation 7 and 8. So this is the very important question. Electric field intensity at point P due to a group of point charges. So if in a system there are number of charge particles are found, then what is the electric field intensity at point P due to a group of point charges? Thank you very much.